Welcome everybody. It's 4 o'clock indeed, so I guess somebody will be pretty tired at this point. So I'm gonna go through my presentation pretty quickly, and then I'm gonna go into a live demo, get fingers crossed. I like to get to know each other because I've noticed that in the talk that I've followed today, not a lot of code was shared. So I'm wondering in this audience who is of course I guess an SRE person, but also has get their hand dirty in code. Who likes to code in this audience? No, so getting their hands dirty, I would say. Okay, everybody. Nice. The reason why I ask is because, of course, I want to make it interactive also for the audience. And if I like demo, somebody will be like, "Oh, I don't understand what's happening." So yeah, very simple introduction about me. Simone Romani. I'm Italian. Work for this amazing company, ING. Not in this building, but close by. Code quality resilience advocate because my department is mobile. So 6 million of customers in ING, only in the Netherlands. In mobile, if you mess something up, you are in the news. So your code needs to be pitch perfect, crystal perfect. I'm going to tell a story of a girl. Actually, in this case, it's a girl that caused some confusion because a lot of people didn't know how this person looked like. But the intention was that this girl would be very happy because she just merged her code in production. Sorry, not in production, but into master. That's a bit too wishful thinking. But in this case, this is the feeling that every person should have at the moment you press the button to merge your code into master. But, spoiler alert, it's not the same person. Sometimes it happens that the same person ends up like this. And then, yeah, the other seems like somebody doesn't want to be like that, right? So yeah, after an endless debugging session that you probably, I don't know if you had to face it yourself, the day after you're faced with the infamous question, why did that happen? Why did I have to spend the night trying to debug my code until, I don't know, 2 a.m. during the night? And at least in my experience, I've noticed that the answer is a lot of times, I didn't think about that. So in the end, it's almost, again, not always, because that's my experience. I've noticed that there is always that little use case that you did not expect and then ended up messing up your whole environment. So it's impossible to think of everything, of course. It's very difficult also to think of a lot of possibilities, but even if you try your best, you cannot assume everything. What if you could at least expect the unexpected and do it right on your laptop? So in this case, I don't know if somebody attended the talk in this room, I think 2 from about the human bias. This specific statement was said, expect the unexpected. And there is a way. And this way is called mutation testing. It's a methodology which is right on your code, which is actually quite simple. It says the words itself says it. It changes, mutate, source code, and then it runs the unit test against this mutated version of your source code. And ideally, what you expect is that your unit test should fail because there is a behavioral drift application. So in this case, the unexpected is literally a new direction that the code has taken. But again, what is something unexpected in code? Because in the end, as I asked you before, we are all coders. What is something unexpected in code? It's a mutation. So in this case, I'm going to give you some example. I'm going to make it very specific. For example, if you have an if statement in your code, that if is basically checking a value is greater than 100. Okay, what happens if you change that slightly to say greater or equal? Did you test that specific corner case? Another example, a method that is supposed to return type, in this case a string. What happens if you return null? Again, this is Java specific code, so sorry if the audience, somebody understands it, but this is just one of the examples. There are multiple examples. I'm going to go through all of them, but this is just to get the understanding of what the concept is. So these are the possible mutations. 2 of the possible mutations that can be introduced in the code. Mutation testing framework runs the unit test against the changed code. And in the end, you get some results, in this case, a report, and you understand how your tests reacted to the mutations. So in this case, as you can, the spoiler alert, it's red, so probably you don't want to see much of that. A survived mutation is what you don't want to see, like almost never, which in this case, there are no tests failed because of that mutation. So basically, you potentially introduced a potential bug in your code and no tests were able to catch it. You will see in the demo what I mean. And you want to strive for as much, ideally 100% of all killed mutations. So at least 8 tests. So it doesn't have to be all of the tests that need to be failed, but at least one. So you need to have at least a signal, so a test that fails because of that mutation. So ideally, in the amount of code that you're writing, let's say, for example, 10 mutations are potentially introduced in your lines of code. Ideally, you want to go for 10, all of the 10 being killed. So in this case, again, the percentage of killed mutation divided by the number of total mutations, it's a percentage that is called mutation coverage. And of course, in this case, the higher it is, the better it is. If you have a lower number, so you have a low mutation coverage, is a signal that you have weak tests. So in this case, your assertions are either too broad or you have criteria that not really make a lot of sense. So in this case, the call to action in this case is get the insights from the mutation testing and then start improving your weak tests and get them up to speed. By the way, does everybody know the picture, understand the picture, know the concept? If you don't, it's the concept of the pyramid of testing. And the concept is that you want to strive for the most amount of unit tests in your application because those are the one that gets you fast feedback, they get you the most amount of test cases possibilities, and they are the least expensive kind of test you can write. So yeah, this is all great, but now comes the convincing part because, okay, this is all great, but why should I do it? Convince me. And that's probably, if you want to do it, that's probably what your manager will ask you actually. That's also what my manager asked me, why you want to do this. Because it makes your development environment better. Development environment is not your laptop, but also the laptop of your colleagues. Because in this case, forget about the code coverage, which is like a number. In this case, this is a meaningful metric. Because in this case, if you have a high mutation coverage, by default, by consequence, you have a high test strength. And test strength is something very important. It's much better, I believe, than code coverage. Because it also, don't forget, it's very easy to achieve 100% code coverage. You can write all kinds of tests with meaningless assertions, achieve 100% code coverage, and very poor test strength. Because if your assertion doesn't really get to the point, you will see what I mean by that in the demo. Test doesn't really make sense. Those are weak. Okay, but then again, what is this concept of test strength give you? Well, you saw in the title of the presentation, it's confidence. Because in this case, having high test strength, you have a different way to look at your software. I like to consider mutation testing as the perfect guardrail around your code, where basically you have built very solid walls around you, and inside those walls, you can do whatever you want with your code. Because you have the confidence that, oh, maybe I'm changing too much, I'm scared. The guardrails, in the case the wall, will protect you. Say, no, wait, don't go that way, you're making something bad. So I like to think of that as an enabler for elasticity of your code base. So the moment you have a safe protection around your code, you gain elasticity and velocity in your code because you can refactor it, make it better with the confidence that you're not going to break anything. So this is indeed what mutation testing brings. I think this is all about the theory, and I'd like to move into the demo right now. Disclaimer, I will make this demo on a Java project built with Spring Boot and Maven as the build tool. It will use a tool called PyTest, and I will give you QR codes at the end for check out the project. I've tried to be not as specific as possible, as generic as possible, because as far as I know, those are, let's say, the best, the most recognized tools around the market. Can everybody see the screen, by the way? Is that also in the back? So all I had to do to introduce mutation testing in my project is literally this. Just include the plugin into my build in my POM XML. I needed to add the JUnify plugin because my project runs on JUnify. By the way, it's not my project. It's actually a fork of the Spring Pet Clinic project. I'm pretty sure somebody knows about the project. I tweaked a little bit the configuration to make it faster, 4 threads and only one specific target class because I wanted to run it faster to showcase. I already ran the initial setup before the demo to show you basically the insights immediately. So I run the framework as in literally a CLI command that I will repeat later. But this is, in order to run the framework, all you need to do is just run this Maven command. And this is what you get as an output. Of course, right now, I'm making very focused only on this class to make it faster. But look, in this specific example, you see how you have 99% of line coverage, but like 50% of mutation coverage. So half of this test don't really mean anything. So you see how easy it is to achieve 100% by having meaningless tests. Concrete example. Let's go to the code. I will scroll down until we reach the, okay, so in this case, you see already this is not looking good. There is quite a lot of red lines over here. And I'm going to tackle one specific example here. Of course, red, bad, and good. In this specific case, the framework was able to replace the return value to null. And not only the mutation was killed, but like the PyTest framework even tells you there's not even a coverage line there. So not even, no test actually went through that code. So even worse. I like to consider like red lines between, because there's also, of course, the possibility that the mutation survived, but I consider a red line a mistake in general. So I don't make the distinction between a kill mutation or coverage. To me, that's already a problem. So in this case, I'm going to show you right away. If I go back to the code, go to the actual production code, and I now go to the actual method, and I say, okay, return null, and I will use the hotkey to run the unit test. Actually, funny enough, if you see, this is actually not a unit test. This is actually an integration test. So this is already a red flag. As a developer, you start to looking at this code and think, okay, what can I do to improve my code? And the first thing I saw is that, wait a minute, why am I running an integration test for all this matter? Isn't it better to create a faster and more to the point unit test? That's what I did. But yeah, look at this. I literally did return null, introducing quite a big bug in my application, and everything was fine. No test, all the tests passed. So this is a problem, of course. So right now comes the engineering part of the problem solving, because right now I'm basically left with an insight. I want to address this mutation. Okay, how do I do it? One could say, I have already some tests here. I can just tweak whatever I have here. But instead, what I like to do, and also what you should advocate your engineers for, think of the problem, but come up with your own solution. Don't follow the current code base. The point is that you need to write better tests. And not by definition, better tests means enrich what you already have. You're able to refine. Test code is cheap because it's never going to go to production. You can write as much test code as you want. There's no problem. So in this case, I looked at this code. I was like, this test code. I was like, maybe I don't want to write an integration test for that, because that would be, if you look at this, there is already some update, because the method was called update owner. But as you can see, there are 6 tests related to the functionality of update owner. But look at the amount of noise this test has. Do I really need to write down all of this for one use case? Of course, writing that one. Another test, same amount of noise. Another test, same amount of noise. So it's a lot of noise that is not really necessary to do. So what I did instead is create a unit test. So again, sorry for all the mocks that I put all over the place, but I wanted to just make it as quick as possible to also showcase you of course. And now I fix all the imports because I enabled the imports on the fly. Sorry about that. Indeed, demo gods are not happy about this. So now I need to fix all of that. Really sorry about that. See, exactly what you said before, Stefan. This was not thought through. Alrighty. So in this case, what I did is basically creating a unit test as specific as possible for this case. So what I did is literally, okay, if you have an update an owner and the underlying service doesn't find anything, so in this case returns null, I am asserting against the response being not found, and afterwards there was nothing else was called, so any other methods were called. So in this case, the test, of course, now fails because I kept the no. But if I now go back to the original code, I have now a successful guardrail that says yes. Okay, now the point is made. So I'm going to run again the mutation testing framework. And imagine that what I just did is basically copy-paste approach for pretty much all the mutations that can be addressed in that specific part of code. But the point here I'm trying to make is that you want, at this point, test smart. Because what I just did, this was a unit test, but right now I'm going to showcase what I mean and refresh the page. And now you see that this now mutation was killed. So now we have increased our mutation coverage. I think we reached just was 52, now 54. So we increased a little bit, just a little bit. But as you can see, look at this. I'm not going to go too much into the demo because I want to keep space a little bit for questions. Potentially, all of these mutations here, all of this kill mutation, if you test smart, you're not going to write one test per mutation. If you test smart, okay, wait a minute. I see that all of these current owner setters are all failing. I can just create one test that asserts against one specific owner with specific address, city, last name, and telephone, and I will get rid of all this mutation in one test. So this is what I mean by so I like to think, get the insights first, refactor your test, and repeat. Test, only test. Don't touch the production code yet. Increase your test strength, increase your mutation coverage until a certain point where you are happy. I like to go for 100% mutation coverage because I don't believe in 100% code coverage, but I believe in 100% mutation coverage because, like I said, I find it a more meaningful metric than code coverage. But only when you have the confidence that your tests are strong enough, that's when you move into refactoring mode for the production code that you can, if you see this code, you'll be like, yeah, maybe I can do something better about this code. That's when you move into implementation mode into production. But don't do that until you have reached a safe place for the test, for a correct place for the test. So this is, I believe, was my process for the demo. Again, I'm not going to go through all of this, but this is pretty much what I wanted to showcase to you. I'm going to give you the links because you might want to also try it out yourself. Come on. All right. So like I said, website of the tool that I've used is called PyTest. Again, I'm not here to promote the tool. To me, it's not important what tool you use because I also don't know which language you're writing your code with. So to me, also, for this audience, is more about methodology. And I like to think SRE, it's nice, observability toolings, all kinds of things that can be done on the pyramid of testing. But I like to think, let's also do SRE in our code, in our laptop. And I feel like this is a good example on how to do it because in the end, I feel if we gain resilience and reliability of our code, it's going to be much easier to do it also on higher step of the. So the website of PyTest, the pet clinic project that I used as a baseline, anybody can use it. I mean, it's available on GitHub for everybody. Everybody scan it when needed. I'd like to ask you just one last thing. I'd like to hear feedback from you about this talk because I'm trying to also improve myself as a speaker. So if you have a few minutes of your time, I'd like you to scan the code and provide feedback about this talk. Any suggestion is welcome. Please be very honest, and I love to hear what you think about this talk. And no phones anymore, maybe. To wait, okay. And that will be it. Thank you.